Okay, let's wait for maybe 1 or 2 minutes, and then we're still seeing people joining at this moment. So just before we get started, just a couple notes. Since today the webinar is a roundtable discussion, and we invite the Matteo from Splunk, Joe from Verizon Media, and Edson from StreamNative, talking about their experience on operate post clusters in production. And it's a roundtable discussion. So if you have any question at any time, feel free to submit the questions through the Q&A panel. And I'll handle over some of the questions to the speakers at some point, and they can kind of answer those questions and share their experience. So I think it's time now. I think we can get started. Thank you everyone for joining the webinar again. And welcome Matteo, Joe, and Edson for joining the webinar and share their experience. And I would get started by let them introduce themselves. Maybe from my screen, from top to bottom. Matteo, you want to introduce yourself?
Hi everyone, I'm Matteo. I work at Splunk. I used to work at Yahoo with Joe, and I was one of the co-creators of Pulsar when we were down there at Yahoo many years ago now. Can leave to the next one.
Edson, you want to go next?
Sure. So my name's Addison Hyam. I now work at StreamNative. I previously was at a company called Instructure, where we deployed Pulsar. I've been a member of the Pulsar community for about just a little over a year now. Yeah, we have a lot of experience running Pulsar in production. Happy to talk about that some today.
Thank you, Edson. Joe?
My name is Joe. I was, my team built Pulsar back ago in 2015, 2016. Matteo was with me throughout the journey. I have all the experience running Pulsar.
Cool. And we're excited to have all of you here. And to get started, maybe you can explain how Pulsar is used in your organization, and we can get a conversation going. And then anyone who wants to get started.
I can start that. I recently joined Splunk, so through the acquisition of StreamNative in last November that we will join, and we've basically been integrating Pulsar in several of the products of the company. So Splunk is a data company, and it has existing products and new products in the various areas. We've been focused on the streaming aspect of the product offerings of Splunk, and we've been basically migrating those into Pulsar. And then as well, we've been supporting all the new initiatives and products of Splunk by having a Pulsar service that all these products are relying on. Basically, we are quickly moving all the data pipelines and data movements for all the products of the company on a Pulsar service. And also is a core technology of the on-prem offerings as well.
Cool. Thank you, Matteo. I think it's really excited to see the Splunk adopt Pulsar and use it in across its product line. And Joe, Edson, do you have any of you want to share like how your organization used like Pulsar?
Sure, I can speak a little bit to Instructure. So Instructure is a education company that makes one product you might be familiar with called Canvas, learning management system used in colleges and primary education as well. And that is a very large application and composed of a lot of different microservices. And so as we were kind of embarking into that world of how to kind of do microservices better and how to already fix some of the messaging between our existing applications, we started running into kind of the very typical messaging problems. And we previously used Kinesis very heavily for some of that, but ran into a number of issues with it, with around its cost, its scale, longer term retention, which we were looking for. And so Pulsar was kind of the natural fit there. And so we used Pulsar, started to deploy Pulsar as the kind of the message bus for communicating between all applications. But also, perhaps more interestingly, as we started to get into the process, we pivoted some other work that was doing change data capture that we were initially going to do onto Kinesis as well to do change data capture via Debezium into Pulsar, and it was a really great fit of being able to have that long-term retention. So that's the adoption is still going on in varying parts of the organization, but the integration is sort of core messaging, and then storage for change data capture is some of the most forward-looking or the most progressed work there, and is really paying some dividends and helping to make that successful.
Cool. Joe, do you want to add anything to that?
Yeah, we run Pulsar within Horizon Media as a hosted service, similar to Kinesis, for all the different business units to run their applications. Mainly, use cases about data streaming, application integration, and data replication. So we are heavily dependent on geo-replication for our BCP requirements. We do it across our 6 data centers across the world. And it is, Pulsar was basically designed with requirements that would help us operate a business like this, a large internet business at scale, with all the contingencies that occur, like cluster failure or data center failure or massive scale in mind. So we have been doing it for 6 years now, and we are pretty happy with how it has matured and progressed, and with the strides it's making in open source too.
Cool. Thank you, Joe. I think both Joe and Edson mentioned about geo-replication, and also I think Edson also highlights multi-tenancy in tier storage. So Pulsar actually has a lot of great features, and like different people who start looking into Pulsar may come from different features. And since Joe and Matteo here, and I would like to kind of ask a question. Initially, when Yahoo created Pulsar, and what are kind of the motivation, and what are the kind of requirements? Any like a story to share about the creation of Pulsar, and that would be very helpful to the audience and understanding how Pulsar was built in the current way.
I think Matteo is a veteran of many failed attempts to build something like Pulsar. So I think one of the largest problems, or one of the most complicated problems we tried to solve was like how to survive a data center outage, right? you have all these long queues built up and you need to drain them when service is restored. And that was a critical consideration for us. And that is the hardest part to do in a messaging system like Pulsar. Like in the normal operating situation, there is no disk IO involved in the data streaming path. It's all dispatched from memory. It's only when you build up a backlog that extends beyond memory that you run into issues with the system. And that's one of the hardest problems to solve. And Matteo can talk a lot more about the challenge.
There are several challenges there, right? But basically, like when the data set is small that it fits in RAM, then it's a very easy problem. And because you always, especially like if you don't even f-sync the data, you just write on page cache, you write in memory, you read from memory, and you never touch the disk. This disk is only touched in background, so it's the OS is doing a good job there. The problem though is that if your dataset is bigger than your memory, so it doesn't matter like if you have like 30 terabytes per node, or like 1 petabyte of storage in your cluster. If the moment you fall off the cliff of your RAM size, then you cannot read the data. So you can write the data, but you cannot read it back fast enough as the data comes in, because the data will keep coming in at the same rate, and you have to be able to read it faster than the data comes in. Ideally, like at least twice as fast as the data come in to be able to recover within a reasonable time frame. As you mentioned, like so at Yahoo, like there were like several other systems before that, but basically like they always have the problem that sure, everything was well at the moment that there is a large backlog, and there can be many reasons for that. The system basically, it reaches a point in which it is unrecoverable. So you keep accumulating data, but you are not going to be able to drain that in any possible time frame. And also it's very difficult to know when that tipping point is, and also how to recover from there, right? Because you have to make decision. Okay, I have to drop this data. Is this data important, or which data? How can I minimize the data loss and so on? So that's why like being able to read the data from cold disk under stress, that was a critical thing that we designed for. And duplication also like adds one more. So it can be like if you don't have replication, you have individual services that might go up and down, and they can go down for a few minutes, 1 hour, and then someone brings it up. Replication adds one order of magnitudes of complication here, because like we've seen multiple times at Yahoo that you had replication across, for example, like US and Pacific and like Asia. And it is all done with fiber cables under the ocean, and they tend to be cut very frequently, at least once or twice a year. There was a fiber cut that takes out all the bandwidth, and therefore you don't have connectivity, so you have to back up data. And these basically don't last for 1 hour; they last for a few weeks. So this is a very, very critical to be able to survive this kind of scenario, because that's the only purpose of the message bus, right? I mean, it's not the only one, but it's the most important.
I think thank you, Joe and Matteo, kind of share a bit about the story of the motivation of creating Pulsar. And there's actually one question coming up is before kind of creating Pulsar, before using Pulsar, what kind of the messaging brokers that Yahoo were using, and what is the journey? Maybe you can share a bit about the kind of the migration journey from Pulsar to Pulsar from the old existing like messaging brokers or messaging technology. Like anything to add on to this topic?
Yeah, can, as for that, Joe can also continue there. But so Yahoo has been around for a while. So it's one of the first internet companies, right? So it has been around for like since '94. Therefore, there was like a lot of technology that was created in the '90s, and that was like very cool technology for that time. And but it was done like for a different scale as well, and a different time. So it started to show the crux at some point, right? But mostly, so for all the like large scale use cases were served by internal systems. There were like a fair variety of messaging system databases that were just built from scratch internally to serve particular needs that were not met by any other open source technology at that time. Now the landscape is very different, but if you look at 10 years ago, there was not a lot of options, and that's for messaging system. There were like internal messaging system based on shared storage like NFS and hardware runs and so on. There were other attempts to build a truly distributed systems. They were not very successful, and therefore, like the old technology will continue because that was the safest solution there. There was also like one thing that is that there were also a lot of like individual products that were using things like ActiveMQ and even later like Kafka on their own. So there was like very like fragmented landscape there, because like you have all these product teams that are their job is to build products, like user-facing products, like I don't know, Yahoo Sports, Yahoo Finance, and like all these consumer products. And they were like basically forced to maintain and operate these messaging systems. And that's not their core expertise. That's not their core mission. They just have to make sure that the product is up and running and the features are getting shipped. And I mean, nobody cares what technology they use underneath, right? But they need something. So that's why we kind of like try to focus on like having a service that could basically serve both the high scale, the large scale platform like databases using Pulsar or like log collection and all this kind of stuff, versus the individual products that typically have like lower scale per se. I mean, except for like mail and this biggest one, but they have typically needs for more sophisticated features like individual acts or like delayed delivery, or like all these kind of things that are more like for a product facing application that they would need.
Yeah, there was also the attempt to build one based on AMQ, so which did not really work out well for us.
I mean, yeah, that was basically the first mandate. Was that yes? Oh, there are all these teams that using ActiveMQ. They have no data replication. They keep losing data. They don't know how to fix ActiveMQ. Can we give them ActiveMQ service? And that was the first attempt that we did. Basically, like having high availability on ActiveMQ, data replication using BookKeeper on top of it, and then data geo-replication on top of ActiveMQ. So like all these things were basically the main ideas, but then there were like two fundamental problems. One is JMS, the other is ActiveMQ, and so the JMS, the problem was that it was a good API in 1998, is not a good API right now, or even 10 years ago. It was already like a very bad model. And ActiveMQ was modeled around JMS, and it was not really designed for scalability, or not the client, not the server, not anything. And JMS was a terribly difficult API to work with for application developers. Like most of the issues were like for developers using not using JMS correctly. So
Yes, I think
very hard to. Yeah,
the AMQ had it could not handle the scale, but more than that, we found ourselves supporting our users on how to use JMS API rather than building the system out. So it was like a large pain point for us, and our use cases are typically not like transactional or anything. It's very it's mostly streaming. So
I see.
it
So
was very difficult, and part of the reason the Pulsar messaging model is very simple is because what we learned from that exercise of trying to get developers comfortable with JMS, and I mean, all these lessons we learned from all these failures, and you can see all of them reflected in how Pulsar is built.
Yeah, I think both Matteo and Joe kind of mentioned a bit AMQ and as well as JMS. We know, I think one of the reasons that people are looking into Pulsar because of the unified messaging model that is able to support both like a mass GQ workload and as well as streaming workload. And this kind of aligned with one of the question here is for people that who coming from maybe traditional messaging queuing area, like using AMQ, JMS, like for people coming from the other side of the world that is using Kafka, what would be the kind of the recommendation in terms of like migration story? Like because those are kind of using two different type of API, and I'm sure that you also face the same situation back in Yahoo, because a lot of applications are used like JMS and as well as ActiveMQ. Like what is the adoption? Like Matteo, Joe,
sure.
do you want to?
So one of the worries at the beginning was, okay, we're going to give them a different APIs, a different SDK, and how people are going to be, oh, we're going to need a compatibility layer for JMS. So if you want to have to switch to have all these products to switch, at the end of the day, like providing like a saner client API, I think was better for them and for us, because like once they saw that, okay, this simplifies a lot my application. I don't have to worry about the reconnections. I don't worry about the JMS sessions and like all this kind of crazy stuff that I have to do to get around and to use JMS correctly, which was very hard. If you say, okay, you're just giving me an API with high-level concept, and that takes out most of the complexity. We can't take out all the complexity, but we try to take it out as much as we can. Like you don't have concepts like connections and so on. So once you have an object, this object is always valid, and you can just keep using, and it's always valid, and so on. They basically like it was compelling for them to switch and to update their application, to switch to 20 service. And if you combine that, and you say, okay, you have all these new features that you couldn't get in TMS and so on. That was kind of like easy to sell. In most of the cases, there are some cases that were like stuck. I don't want to change my code. I just keep using the old system. I said, sure, go ahead. It's up to you. But it was not terribly difficult. So like if you can show that the advantage for the developers are typically like are kind of like inclined to switch the API. And typically, like switching the API is better than having like adapters, because adapters are great, but in some cases, yes, you kind of like lose a bit that the semantic is not 100% the same and so on. So what I'd say is that you have the kind of the same concept. It's just that so it is not. It is less difficult than it seems to switch from one API to another. If the new one it gives you precise semantics and simple abstractions.
Yeah, I would say the same thing, that when people think of rewriting something, they think, okay, it's as complex as the old system is, but actually it's a lot more quicker and simpler. You can probably have your basic setup running in less than a day. So there is no smooth transition, like you cannot switch for the APIs are very different, but the effort involved in that migration is much smaller than most people just assume when they say, okay, I have to rewrite the system. It's as complex as my old system. And when you get to understand how the Pulsar APIs are structured and how easy it is to write an application, then you realize the simplicity of it, and then it's much easier for people to make that jump. And also the maintenance of the application going forward, right? The amount of time you invest in that also makes a significant difference.
Cool.
And I would just share, so the experience that we had, kind of speaking a little bit to some of the, both coming from messaging systems where we use Kinesis pretty heavily, as well as other AWS offerings like SQS. What we often found is that teams were either using one API, sort of not in its ideal use case, right? Like where something that SQS may have been, potentially a viable option, because they needed some more retention guarantees, they used Kinesis, but that didn't have an API that was necessarily great for kind of doing this more pub sub model. And so as we kind of could present Pulsar with the unified messaging model that can overall reduce complexity, because you don't have to think as much about these two very different models and how they don't necessarily mesh very well, being able to say, here's a system that has these pub sub semantics that you're probably fairly familiar with, granular topics that map really well to application domains, along with then the ability to have long-term retention and all these other concerns that often exist as particularly as applications grow. The developers that we would within the organization were very excited and wanted to go, were excited to have all of that in one package, as opposed to the complexity being spread across multiple different systems. And once again, we kind of found a similar story of that. That reduction in overall complexity with a model that handled most of that was well worth the cost of any switching.
Yeah, there's also the additional simplicity that comes from running it as a hosted service in your organization, right? Instead of every team running their own MQ or Kafka cluster, you have one team operating this for you, and it basically frees up the application team from having to manage their own setup.
Cool. Thank you all for you kind of sharing a bit about the API and slash kind of adoptions migration story. Edson, since you the Instructure, you have been in Instructure for a year, and you probably one of the main driver of adopting Pulsar in Instructure. Like, what is your kind of adoption process for Pulsar within Instructure? Is any like experience or best practice you want to share?
Sure. Yeah. I mean, I spoke about this at Pulsar Summit. I'd really encourage anybody to go. In fact, if CJ, if you want to link those, or I have those slides that I can also link.
Yeah.
But where I talked about this a little bit more in depth, but kind of just to summarize, really, we were able to get everybody on board pretty quickly by kind of really showing that value proposition of Pulsar's unified messaging model. While we couldn't just go, there's definitely not as much vendor support a year ago for just using Pulsar in an out-of-the-box package. That our investment into it, we felt was going to be very worth our time and energy put into it, because we would get such a broader set of capabilities out of the box. And that really was sort of the message that we led with, was these APIs that Pulsar provides, the ability to have long-term retention, cost effectively with S3, with unified messaging, by leading with some of those, the kind of what that gave us from a developer perspective, really made it clear the advantage that Pulsar had relative to other messaging offerings, that we were considering. And that, more broadly speaking, was focusing a lot on Pulsar, because of everything that comes with out of the box, like multi-tenancy, security, ACLs, all these things that we got out of the box. Instead of building those things on top of, Kafka or some other messaging system that, that where those components aren't as first-class citizens, we could really focus on the real high-value out business integrations of interacting or creating, for example, Pulsar sources that made it really easy for teams to ingest data into the system. And that was really proved to be true as well, is that because we didn't have to spend as much time building all these other requirements that we would have had, that we were able to focus more on the things that actually drove business value, as opposed to the nuts and bolts of operating a large cluster, multi-tenant cluster, or managing lots of individual clusters. So that was kind of the message that we had across the organization. As we kind of explained that, it really resonated well, and frankly, it made adoption and the getting the approval for that project and the adoption go pretty quickly.
Cool. Thank you, Edson, for sharing the adoption story. And so a lot of people who are looking for Pulsar, they want to get started. But one of the challenges that usually coming up is about what is the hardware specification, and what is the capacity model, maybe a go to production checklist. Is there anything you guys want to share a bit about I would say the mental model of the whole hardware selection / capacity modeling in terms of planning a production ready Pulsar cluster?
I think we talked a little bit about this in our Pulsar Summit talk about the kind of configurations we are using, but we have gone through many iterations of the configurations, and we run our own benchmark tests before we pick our hardware. But the fundamental premises are the same. We try to put the BookKeeper journal on a separate device, and our recent very latest model is using a very small PMM device for the journal. It costs very little, but we can do like 600 megabytes, peak throughput through one host with 4 NVMe drives. That's a lot. I mean, that's a benchmark brag, but normally we should be able to do quite a lot through one host with a PMM device. And even if you use an NVMe device, for journal, that would scale very well. For us, persistence and guarantees are important, so we don't try to disable F-sync and all these tricks, that has the risk of data loss. So we try to keep throughput along with the durability guarantees we get. So usually when for our use cases, we don't try to manage how users use the system. The way we run the services, we have a hosted service. Somebody wants to use the system, they come and ask us, hey, I want this much, I want to store, X terabytes of data. This is my, rate of messages, coming and dispatched, and this is my peak rate, average rate, and we don't really get into the details of how many namespaces are there, or how many topics are there, or what they choose to replicate to where, and those are all done by the users themselves. So we consider ourselves in the business of providing capacity, and users can build applications and actually architect them in a way that makes sense to them within that capacity provided.
Matteo?
Just a bit more color there. So one thing is that at Yahoo, like, typically like deployments are on-prem, right? So that's kind of like, and also like we had the luxury of saying that testing like all these kind of like SSDs, different models, different batches of them, and say, okay, which one is the one that performs better? That's buy all these boxes of this with this custom configuration. That's not generally true somewhere else, and especially if you're in cloud where you don't have. I mean, you have choice about you have a bunch of predefined choices, and the basic choice that you have to make there is, do I want to use like locally attached storage to the VM versus I want to use replicated storage like EBSs or persistent disk in Google Cloud and so on, right? So that's kind of like the first choice that you have to do when you're in cloud, and it really depends on various things like what is your throughput and what is your cost, that how much do you want to pay for that throughput, right? The cost per gigabytes per second, kind of, and what kind of reliability do you need? The thing that is very different from on-prem to on cloud is that on-prem, like when you write on disk and you have sync on that disk, unless you physically break the disk, you can record the data, right? You can, even if the machine is completely toast, you can just send someone, take the disk out, swap it on a different machine, and read that data back again, right? So once you have the fsync, you can have you need to have like a mechanical failure to lose that data. And if you do replication, you need to have like a multiple mechanical failures, 2 or 3 or how many copies you have. So it is a very good guarantee. But on cloud, if you write on the locally attached disk or that VM, when the VM is gone, the disk is gone. So the disk life cycle is tied to the VM life cycle. The VMs can be terminated at any point in time, not just by you, but also by the cloud provider. They just kill the host and migrate your VM somewhere else, and the disk is empty. So the data durability is much lower on those devices, and at that point, it doesn't make sense to fsync the data because that you can't recover it. So for anything that requires like durability, and like say I don't want to lose data, or I have I want to have a much higher threshold for losing data, better said, you typically want to use EBS volumes or persistent disks, and use fsync on them, because like if you don't have sync, then the data just stays in page cache of the VM. VM is gone, you know, get flashed on the EBS. And EBS has, and Google volumes, Google persistent disks, they have all sorts of different tricks on how big has to be the disk. They have different kinds of disks and so on. Typically, the throughput is tied to the size of the disk, but then there are like all the different tunables there. That it can be very complicated. And just read through the documentation of that. And I mean, all these things typically are not a problem at the low to medium scale. Basically, everything will work there. Just write on the EBS and fsync the data, and that's about it. If you start wanting to say, I want to write like, I need to write hundreds of megabytes per node, then it becomes more tricky because you like how many disks you get to attach to each node and so on. That becomes more important questions.
Edson, do you? Yeah.
Sure. You know, where in Instructure we were AWS shop, and we ran Pulsar on Kubernetes. And honestly, one of the things we really liked, not only about Pulsar's design, but also about running on Kubernetes, is that we pretty much as possible deferred capacity planning. because we had an environment that was very flexible, we could start with 4 gig JVMs and for brokers, and then we could very quickly scale those up to 16 gig JVMs as we sort of saw how the system was performing for some new workload that was coming on board. And so honestly, that was what we tried to do in most instances was have some idea of what we ran some tests across a few different size JVMs that were fairly straightforward, just Pulsar perf to kind of get an idea of how certain things performed. And then with a little bit of those heuristics, we could pretty quickly react to say, okay, we need to add some more brokers or some more bookies if it's more on the write intensive side. And similarly with EBS volumes, particularly on Kubernetes, the ability to we used for journals, we used the provisioned IOPS EBS volumes, and we used then just normal GP2 EBS for the ledger stores. And in both those instances, we have some flexibility about adding more capacity to those disks. And our scales weren't so huge that we had, that we would start need to worrying about adding multiple disks at that point. Although even that is also fairly straightforward with Kubernetes that takes care of all the creation of volumes, does transparent volume resizes, and you just need to restart your pods. That really allowed us to focus on less on super pinning down what the most optimal hardware is. Often one of the benefits of the cloud is it gave us a ton of flexibility, and Pulsar's architecture supports that working that way really well, of letting you kind of get started with some base configuration and over time adapt that as your needs change, all in the running system without having to suffer downtime or outages as you change those out. So we made heavy use of that, and it worked out pretty well for getting a system that reacted to scale pretty quickly. I mean, what we had, getting it to be fully auto scaling is, a different challenge, but being able to very quickly add more capacity and change kind of the certain parameters of the system to be cost effective relatively easily.
It's a very interesting idea. It's a very interesting experience. Like you leverage the elasticity of both Pulsar and Kubernetes for like choosing the right resource, right instance of both on disk and as well as the size of the instance in production based on the workload. I think that is a really good experience. And I think all of you kind of talk a bit about the disk and in terms of the journal and sizing the kind of the journal disk as well as sizing the ledger disk. And one of the, I would say, the commonly seen not problem, but issues that coming up is we like Pulsar usually see out of memory, out of direct memory, and so what is your recommendation in terms of tuning the memory settings and maybe sizing the memory of the given instance, and as well as the sizing the number of the CPU core of the instance? Do you have any recommendation to the audience?
So one thing that we're not doing well in the past, I guess, and to some extent we should also improve a bit, was to be more parsimonious with memory, right? So in some that stems from the fact that the typical deployment was on-prem, in which you deploy one process per like physical node, right? And that physical node will have like at least 30 to 60 gigs of memory at least, and you can just use everything, right? So in many cases there were like by default we had like very big caches and so to speak, because memory was never a problem, right? So don't worry about that. Just use a whole bunch of it, and don't put many restriction on that use of memory, because we have it and it's not worth time to spend that. We can just spend on something else, right? That said, I mean, with memory, like basically you're trading memory for throughput at that point, and or for simplicity in implementation in some cases, and and that's basically like you can test that. You can do like all these sorts of like high throughput use cases and so on. And the moment you try to tune that for a very low volume and low throughput and low memory, or like low memory, but try to do as much throughput as it can through that smaller system. That were like this auto memory. I think in the past few months we've been doing kind of like some improvements there. I think there are some more that should go through to make sure that if there is a very low amount of memory, we shouldn't try to use much more than that, and give that these exceptions. So as a recommendation is that if you have this throughput, just give it memory. That's kind of like I think. Having said that, we shouldn't give exceptions if we don't. But like in both BookKeeper and brokers, there are caches, and if you have like throughputs in the hundreds of megabytes per second, you want to have buffers with room to sustain hiccups, right? And at high throughput, a hiccup can mean gigabytes of data that has to be staged into buffer before they can be brought into the disk, right? So if your disk has a hiccup because I don't know the SSD is doing internal GC on the disk and so on, or there is some activity on the disk, or there is something else, you need to be able to buffer for that. Of course, you cannot buffer for like infinite, so that caches can only take you so far. But like the buffer basically, it just helps to smooth the pipeline from client to broker to bookie all the way through the disk. And the higher the throughput, the better have more space to have more time of buffer.
Yes, some of them I think we recently addressed by adding some back pressure knobs into the system. But basically, what Matthew is saying is correct. Like we have brokers from 24 gig to 48 gigs, 96 gigs, and you essentially trade off throughput. You can push less through the smaller systems. And it's the same problem. Like if you have a hiccup, it's a fully asynchronous pipeline. Things will start queuing up in memory. And that's the trade-off you're making. For low throughputs, maybe it would work. Definitely, there are improvements we can still do in this area.
I'm really glad to see that there's a bunch of the changes that add to either in the broker, in the bookie side, on the back pressure, on improving the whole OOM situation, and do much smarter allocation of configuration by the system itself, so people don't really need to tune those settings. Like back into kind of in the operational side, since Pulsar has multiple components, like especially we have one data storage that is BookKeeper, and the other like kind of some people like it and some people hate it, which is the famous ZooKeeper. So I would like to see what is kind of your experience on operating both BookKeeper, like which is critical since it's the core data storage, and as well as what is our experience on operating ZooKeeper in production. That is also critical because it stores a lot of metadata there. I
think we contributed weight back to the community as a result of hitting a bottleneck in ZooKeeper, where we tried to run 1 million topics on one ZooKeeper, and that is why we made that contribution back about how you can split your metadata across more than one ZooKeeper. In general, I think BookKeeper is very, very stable. I mean, like in terms of data reliability and operational scalability and everything, we like BookKeeper a lot. It's I think it does its job very well. Zookeeper, there are issues, but they're not related to scale per se. It's basically bugs in Zookeeper, which we occasionally run into, and they are the things that really cause us trouble once in a while. I mean, if at all, like I had one wish, it would be like, okay, how can we kind of reduce our dependency on Zookeeper a bit?
I mean, that also add that, I mean, these kind of bugs of Zookeeper, like some of the things are mostly evident at large scale, right? If you're so is that if you have a small cluster and you hit those, then probably nothing will happen. The moment that you have a large cluster with a lot of data, a lot of process connected to that Zookeeper instance, and there is something wrong there, legal action takes more than what it should be reasonable to take, and so on. Things can go south quicker. I mean, and then a small class probably won't experience anything there. Having said that, yes. So Zookeeper has lots of good things and some of not so good things. So the main thing that scared off many users was that it was the development there kind of stalled for a few years. There was like some stagnation. I think that's kind of like it picked up in the last 1.5 years or so. They've been making new releases and so on, and there are like some new exciting features that been pushing on. At the same time, I think that like long term for Pulsar, I think it's good to look at the reduced dependency on Zookeeper. I mean that was always the idea. Is just like when is the good time to do that. And I mean we've been talking that for a while now. I think we kind of have the reasonable idea. It is not like a 1 week project. It's a multi-step ongoing effort that will be going on in the next few months at least, and with the first steps basically meaning that we need to be able to aggregate all the usages of metadata into one single layer, and that we can basically swap out that layer and have multiple backend implementation for that. With the tricky part there is that we need to be able to support different semantics for different systems and design what this common layer look like based on what we need and also on the common denominator across multiple systems, which can be tricky. But I think that's we're not doing anything so special. So hopefully we should get that done soon. And once we have that, then basically we are in a much better spot, and we can basically plan for what can we use in multiple cases. Like we can use different coordination and metadata backend store, or we can use an internal one based on BookKeeper. There is already work on that front as well. So that's kind of like the direction that we want to move on. And I think that right now is a good time to do it.
Mm-hmm.
Thank you for like I know like Zookeeper itself is a kind of very hot topic, especially like in the Kafka raised the idea of removing Zookeeper dependency. I'm really glad to see like Mathieu and also the PMC is kind of thinking about how to improve the whole metadata management within Pulsar. And since we have a very limited time here, and Pulsar has a lot of features like in terms of like multi-tenancy, geo-replication, and we don't have time to cover all the topics in this webinar. We probably have a follow-up webinar if you guys all have time. We can talk about details in terms of like features. And I would like to kind of close the conversation with 2 questions, and then we can move to a more freestyle questions that answer some of the questions raised by the audience. So my last 2 questions is more coming from what is your go-to production checklist that you can share with like the audience, like if people want to plan use Pulsar in production, that this is something like you should check before you go to production. And the second one is if you have any war story or like about running Pulsar in production you would like to share, and that please share maybe one of the war story, or like how do you solve the problem in production. And yeah, that would be kind of the 2 of my last 2 questions.
I'll just
Yeah, great.
I was just gonna say I'll just really quickly say you know, for somebody running in a cloud environment, I think the most important thing that we really found in understanding Pulsar was really getting good visibility and you know, good sort of logging and trace kind of figured out for Pulsar in such a way that when we did have issues, we could kind of pinpoint those issues quickly and have a good understanding of you know, what could go wrong, and alerts that kind of tried to highlight those. And I don't have much on war stories. I mean, had plenty of issues, but in the allowed time, I'll let these guys share some of theirs.
So as far as adapting, you know, a new release or, you know, new package into production, right? Pulsar is very, very suited for this, in that you can do a fractional deployment. You can put a broker and 1 bookie, you know, new software into production, and, you know, the world will crash, the crash and burn on these 2 instances, but your system will still recover and run fine. So I consider this a big advantage, right? You can roll out you know, a new bookie release or a new Pulsar release on 1 or 2 hosts, and your system will run in spite of failures. So that is a, you know, good test to do, and we do that while we deploy to production. In terms of war stories, you know, like, you know, I think, you know, as I said, right, we built Pulsar. We started out small, 40,000 messages, 2 brokers, 4 bookies, and, you know, we kept on growing, you know, and one day we reached 1 million topics, and we had data center outage, and we could not start the system back up. I mean, the system would run fine, but if you lose power and you shut it down and you restart, it would not come up. Right. That was a challenge we faced, partly because, you know, Pulsar was, you know, able to grow, like, you know, without ever shutting down for over 2 years. And, you know, we never ran into this problem before. So that was a good story to recall, right? You know, we reached 1 million topics. We rolled multiple releases into production throughout that, you know, growth. We kept running, and then one day, you know, we could not, you know, shut down the system and restart. And that's how the PIP8, you know, where we said, okay, we have to run with multiple zookeepers came about.
But the backstory of that was basically that this cluster failure was triggered by Zookeeper that was basically just crashing. The literal action was taking minutes, so that's why it was not working. And that was one. And the other issue that was there is that the topic lookups were being done through HTTP at that point, not through the protobuf channel. And the C++ client was not keeping the connection alive. And therefore, and then there were like thousands of clients, literally thousands, and that were trying to reconnect in multiple with thousands of topics. So we were basically making millions of HTTP requests and TCP connection that were basically crashing the whole machine just to making those lookup requests. And basically that issue was handled by by having geo-replication, so that we have data copied in all the regions, so that we could fail over to all the regions, the clients, and so on. And in the same region that we had to fix it, we fixed it with IP tables and putting rate limiting on TCP packets. That was fine to solve, but yeah, that's how we got out of it. And my favorite one though was that at some point we had corrupted data on consumer. Consumer was crashing, getting corrupted data, and we didn't know how this data got corrupted. And eventually, like we basically like we saw that the data itself was stored correctly, but it was just sent once corrupted. So the same data was being resent correctly, but it just got the data corrupted once in a few occasions, and eventually it was tracked down that there was some hardware failures in some network equipment that corrupted data packets, and somehow the TCP checksums were resulted correctly. So that was in theory should be possible, but again, TCP checksums are not super strong, so that can happen, and that's when we added CRCs at the messages self calculated by the producer and checked by at any level, like we check these CRCs, so that if the data gets corrupted between producer and broker, the data will get resent. If it gets corrupted during geo-replication, it will get resent again because it gets discarded once it gets received. So at any point that the data is exchanged, the checksum is checked so that we are not storing corrupted data. So that's what was kind of like why we added those checksums at the application level.
Thank you, Joe, and thank you, Matteo. I think share those kind of war story, and it's really great to hear from you and understanding why Pulsar introduced some of the features, for example, like the CRC, like checksum. I think we're kind of over a bit of time, so I would like to kind of close the conversation. We'll probably schedule follow-up webinars for talking about more deeply into individual features, like how to best use some of the features. And for any audience who is going to stay here, I think there's still some of the questions that maybe Matteo and Joe, since still have time, we can answer those questions. And if people have other events or other meetings to join, feel free to leave the webinar. All these will be recorded.
And any questions, I was just going to say, if any questions don't get answered here, please feel free to ask them in Slack as well. I mean, I'll make sure to try and answer them. I don't know if Matteo and Joe can also try and answer any in Slack that you might have.
Yeah, I can stay a few minutes and ask any that to us.
So I'll probably just go through some of the questions, like how do we maintain geo-replication in Kubernetes? Do you have deployment file to enable geo-replication in Kubernetes? I think Edson, you probably the best people to answer that.
Yeah, the way that we did that was by in Kubernetes. It's not too crazy. Run a ZooKeeper in multiple different regions, and then use a service that gave that a stable IP, and then we just had network peering that allowed us to connect all of the ZooKeepers together. So it's not anything too crazy. You're just gonna have like a stateful set with a couple pods that all hooked up using a VPC peering, and then we used external DNS. It's a Kubernetes that allowed us to give stable names so they could talk to each other. Be warned there's some trickiness there with having ZooKeeper work with DNS in the way there, but happy to answer more questions about that if you have them in Slack.
Cool. Thank you, Edson. What are the challenges Verizon faced during the migration to Pulsar from old messaging vendors? Joe, you want to cover a bit, or you already covered a bit before?
Yeah, it's basically a different API, and the programming model is simpler and easier. So it's developer mindshare basically about how to what is the effort involved, what does it take to move, and then there is definitely a transition involved in when you have to write to both systems, and read from both. But usually this kind of switches happen, when people are evaluating their tech stack. What is the future? What is my future stack going to look like? We have found that is a good point for us to, make people move to Pulsar.
Thank you, Joe. If you have any question about the migration story, I think you can also reach out, Joe, in Pulsar Slack channel. I think this question, Matteo, probably the best people to answer. Have you considered other storage system comparing to BookKeeper? Or maybe Joe, I'm not sure who want to answer this question.
So I would say no, in the sense that the first experiment was on these highly available ActiveMQ. So that's when we gained the experience on BookKeeper, that we started working with BookKeeper and with the BookKeeper community and so on. And that was the most solid part of the stack, right? So we didn't have any issue there. We saw that, okay, sure, we need to add a few more features for things we need and so on, but this is working well. We just need to change everything else. So that the basic idea that when we rewrote Pulsar was that we know what's working, and it is the storage and how we use the storage. What's not working here is the ActiveMQ and the whole broker and interaction with clients. So we need to fix that, and we don't want to rewrite the storage. The storage is working, and again, that's why we didn't really check anything else at that point, because the first experiment was. So at the beginning, it was an experiment to use BookKeeper in ActiveMQ. That was some proposal. So BookKeeper at the point, it was a project from Yahoo Labs, and that's why that was okay. That we could try to do that with ActiveMQ and provide ActiveMQ service, and it's okay, sure. And that was kind of like the best part of that system. So that we didn't want to abandon that.
Okay, thank you, Matteo. And if you have anything related to this question, you can also talk to Matteo on a Slack channel. For streaming use cases, the mastery in topics have long-term retention. Is there any real-world insights on that you can provide from managing these long-lived streams? Who wants to answer that?
I think the tiered storage is a very good solution for this. So we are actually building out the system along those lines. For our long-term storage, where we have to retrain machine learning models on historical data, this is the approach we are planning to do.
And one of the big things that we really like Pulsar and tiered storage for was being able to do change data capture and basically have a view of a table, a database table that we can view as a stream where needed and compute other views, other aggregations of that data. Trying to move more towards that real sort of unified batch and streaming, that we could have our streaming system be the source of most of our data rather than having to push together a batch, a batch dump of all of our database data, and then a stream of some database changes. We could just kind of have one system to service most of those out, and that worked for a lot of us because we have pretty small tables of sharded across all our customers.
Matteo, do you want to add anything to this?
So the question there is mostly that so that two things, right? what is the cost of storing that amount of data, and the other is also like I want to have like this infinite retention concept, right? So that's what basically the tier storage gives you. If you don't have say that if I just need to have a shorter retention, so it's still long, so it is longer than say a queue, because it's not just a few minutes, it can be hours or days. But sorry, if it's you can still do that without tier storage, right? So if the amount of data is not huge, you probably don't need a tier storage. But tier storage is nice to have in all the other cases. But having said that, I don't think that there's kind of like any particular problem in keeping data longer in BookKeeper.
Yeah.
Except that, sure, S3 is cheaper because you don't have to keep a VM running. But from the functioning perspective, it will be fine. And
cool.
And you can add more bookies if you need more storage, and you can use auto recovery if one node fails and lost its copy of data and so on. So like all these primitives are all there. It's just that you have the additional options of using tier storage if you want to lower your cost or have like very long retention.
Okay, thank you, Matteo. And thank you, Edson and Joe as well. Does Yahoo and Verizon expose Pulsar directly to application teams to use or some abstraction layer built on top of that? I think that is an interesting question that is actually coming out in many different ways, is because I know a lot of internet companies is using building additional layer on top of Kafka, like Uber built their own proxy there or abstraction there on top of Kafka. Netflix is probably doing a very similar thing. And I think it's interesting to hear like what is the experience of Yahoo or Verizon using Pulsar internally on providing the service.
So we do provide a wrapper on our application libraries. We don't, I mean, Pulsar itself is raw behind the wire, and it's basically encapsulates a few things about, security. So, Pulsar has, pluggable security and authentication and authorization model. And, we provide a library that, comes with that built in, which is, a wrapper on top of the Pulsar library. That's the level of abstraction we do. And also we kind of try to deal with, the changes that happen between, Pulsar versions a little bit on that line, so that, the developer APIs are fairly constant. I mean, it's not a problem because so far Pulsar has been wire protocol compatible across all its releases, and everything still runs. So we have never run into that issue, but we have the ability to deal with that if it arises.
Cool. Matteo, do you want to add anything to this topic?
I mean, no. I mean, just that. So there's no different abstraction at the API level, right? So it's the same API. As you mentioned, yes, there's a proper. I mean, I don't know now, but when I was there, like, it's just a minimal wrapper, like also like before, like for things like before being called Apache Pulsar, it was called Com Yahoo Pulsar, right? So like all these kind of things, you don't want to have developers to change their code because of this renaming. So that's kind of like what the wrapper was doing, but there are no difference in concept or APIs.
Okay. The next question is more or less about the monitoring, and I think they're kind of two similar questions. Which parts of BookKeeper to give metrics are the most important one to monitoring in production to detect problems quickly? And a similar question, is there any advice on the monitoring Pulsar cluster on Kubernetes? Like maybe some advice here.
I mean, I don't think that there's particular advice in very specific to Kubernetes or versus like other kind of deployments. But for kind of metrics, like if you go like on Pulsar versus BookKeeper, so on Pulsar side, things typically you want to make sure that to familiarize with all the kind of dashboards that are there. Because for example, in hand chart includes all these dashboards, and understand what's the meaning of each of the charts. Because if someone added the charts, it means that someone at least looked at the chart at some point, and so if it's there, it means that it's something that you should know what that means in some way. But in terms of what's more important, I mean the rates in and out and backlog, right? That's kind of like meaning that your application is able to keep up, or the system is able to give data fast enough. And second to that, also the latency. So there are different charts for latencies, for like latency perceived by the broker to the bookies, and there are like different breaks down per broker or per topics and so on. So if there is any write latency that issue on the BookKeeper, that typically would be rippled down to the broker as well. On the BookKeeper side, again, the throughputs in and out, the latency of the add operation, read operation, write cache sizes, I think that's kind of like the most important ones. And on ZooKeeper one, I think we have been adding some of the metrics in ZooKeeper. ZooKeeper per se doesn't have a lot of metrics. It doesn't have any metrics that gets exported to Prometheus. So that we did added that and exporting that in the ZooKeeper that we ship out. So I think that they are typically the most important one, that the latency that you can write on ZooKeeper, and if there are any spikes of write and read operations. So we kind of like broke down the request on ZooKeeper by writes and reads, so that we can understand what's kind of like load that we are hitting on that ZooKeeper.
Yeah, I think GC metrics is something that we pay particular attention to, because GC process used to have, I say used to have, because I think we have right about now overcome that problem with but they say they used to have a significant impact on our 99 percentile, and we used to pay very close attention to that. The ZooKeeper znode count is something that we watch. We don't want it to grow like without any reason. And because we run at a really large scale, we watch the snapshot size too. I don't think most people normally run Pulsar at this scale, but like a million topics. But the snapshot size is something that we pay attention to.
Thank you, both of you. I think that those are kind of very useful insights. Probably the last one question is there any single feature that could justify the adoption of Pulsar over other solutions? And what is the related use cases, minimum throughput highlighting this feature in production? I think anyone want to kind of kick off the discussion of this one?
I think it's hard to kind of say this is the one feature. Any tiered storage is really great for if you have long-term retention use cases. It just makes the management so much more cost effective to be able to put longer term data onto S3. But at the same time, if you're a company that has lots of different teams and you're trying to run Pulsar as a service, multi-tenancy is save so much time around trying to have to figure out a strategy for doing that, on Kafka or even on top of a host offering like Kinesis. And so really for me, the combination of how all those features kind of come together to make a pretty compelling offering is that it really proves its worth. And part of that is it scales, really well. You can use Pulsar in the pretty small scale and get started with a number of topics, but you can really it can really grow as your needs grow, as your usage grows, because of its rich feature set and how all those different things allow you to have a lot of flexibility and choice on what you do with Pulsar?
I would say that there are different dimensions on which this works out, right? One is the operability aspect of running Pulsar, right? It's easy to operate, it scales well, and fairly runs reliably well. Georeplication and all is super simple, right? The other thing is from the application developer's point of view, right? Think like you have a like sales coming up, or and holiday coming, and your traffic is going to shoot through the sky. You want to scale your application. All you're going to do is scale up your number of consumers. You're not going to repartition your topic and move data around and all those things, right? So there are two different dimensions on which this works out for us. Like operability and developer ease of use, and both I think are really important. And they matter. I mean, especially the shared consumers, scaling up and down, during peak traffic times is very, very valuable, for users. And I without getting the operators involved, and that's a critical part, right? You're just a Pulsar user, and you can scale your consumption up and down. Very hard to do in other systems.
Okay. I think we probably have one last question. How fast is Pulsar compared to Kafka for messages around 100 KB or more? Matteo, Joe.
So the message size at that point is not really very relevant, in the sense that typically, like in both cases, messages are going to be batched, right? So even if you send like 1 kilobyte messages versus like 100 kilobytes, at the end of the day, they're going to be sent out like 100 KB batches. So that's kind of like the same. So you can compare the throughput as well as for like 1 KB versus 100 kilobytes. We did a bunch of benchmark. Actually, yes, we with I also like a couple of years ago, I work on creating a framework for benchmark for this open messaging benchmark framework that we started at StreamNative, and that basically was trying to be an unopinionated, as much as unopinionated can be, but that was intention and the guiding principle to write like a framework so that you can basically attach drivers to test messaging systems. And in different scenarios, in different environments, we kind of like demonstrated that we were able to write faster than Kafka. Again, people will contest that and say that's I don't know, that's one use case. I think that's kind of like yes, it is a few use cases. I mean, you have to pick one that I think is for example, like single writing, either a single partition produce a throughput test, or like a fixed throughput latency test. So that I have, let's say, 100K message per second. What's my latency on that condition? Or saying, okay, what is the max throughput that I can get within some kind of latency, after which my system, I cannot use the system. In all these cases, that we shown that we could provide much more throughput than Kafka and with better latency. You can replicate all these tests in your environment, and there are a few reasons for that. So it is not that yes, we do it. It is faster. That's it. You have to trust it, and that's because we are better and smarter. That's not the case. There are few reasons for that. And there are few specific reasons in how Pulsar and BookKeeper can achieve the pipelining of the data and basically remove all the obstacles between the producer and the disk eventually, right? You want to just like show up data on the disk as fast as you can with the minimal obstacles. And the way that data is replicated in BookKeeper is very different from what Kafka is doing, and it is much more efficient in how the data can flow through the system. And I believe that explains the difference in throughput and the difference in latency, especially. So all these benchmarks are replicable. You can just run it on your AWS cluster, or just run it against your particular deployment and see it for yourself.
Thank you, Matteo. I think I also share the link about the open messaging benchmark. That is the benchmark Matteo created. Feel free to check out the details. And I think you can also search in the internet. There are probably a couple articles that people might try to reproduce this benchmark. You can check out those articles to see this benchmark. And if you want to run the benchmark, I think that you can use that as well. Matteo, sorry.
Yes, I also published some slides a while back, so
okay.
I can link it here with my results.
Okay. I think that are all the questions. And if I miss any questions, feel free to ping Matteo, Essen, and Joe in the Slack channel, and I'm sure they're happy to answer any questions. And that will be all the kind of the content for today. And we will try to find maybe next time on